Hello, it is noon, so we'll go ahead and get started here. My name is Ali Japoris. I'm a sustainability specialist with the City of Bozeman, and I'm here today with Blake Ringenson. Let me know if I said your name last name wrong, from the Northeast Energy Efficiency Alliance, and Devin Felicia from the City of Missoula. We're excited today to be talking about heat pump water heaters and efficient water solutions for your home, water heating solutions for your home. So what we're going to do is start off with a presentation from Blake and about just what a heat pump water heater is and what you need to know when you're thinking about installing it and seeing if it's a good fit for your home. And then we'll pass it off to Devin to talk a little bit more about local incentives and incentives kind of throughout different parts of Montana and to share some results from different satisfaction surveys we've had from people who have installed heat pump water heaters in their homes. And we also have Garden City Plumbing here to share a little bit about their experience installing and using heat pump water heaters. And so we'll do questions at the end. If you have any questions during, feel free to drop them in the Q&A or the chat, and we will come back to them at the end of the presentations. But let's go ahead, and I'll just pass it off to Blake to introduce yourself and start your presentation.
Thanks so much, Ali. Let me share my screen, and please let me know that you can see it okay. Give me just a second. Can you see that okay?
We can see it.
Looks good, Blake.
Perfect. Well, thanks all for joining. Thanks for the introduction, Ali. My name is Blake Ringeisen. I'm an Energy Codes and Standards Engineer at the Northwest Energy Efficiency Alliance, NEA, out of Portland, Oregon, although I live in Whitefish, Montana. I'll be presenting today on behalf of NEA's Hot Water Solutions program. So before going into the content, I'll just tell you who NEA is and a little bit about Hot Water Solutions. NEA is an alliance of about 140 electric and gas utilities over the 4 Northwest states. We're working on behalf of the 13 million energy consumers in the region, dedicated to accelerating energy efficiency, leveraging our regional and national partnerships to advance the adoption of energy efficient products, services, and practices. One of our programs is called Hot Water Solutions. This works directly with the market on the supply chain side, typically manufacturers and distributors, and also installers of water heaters to give support and resources in the field through workshops like this one that we're giving today, awareness campaigns, and regular outreach. So that's our Hot Water Solutions program. So we can jump into it now. Heat pump water heaters, an overview of the technology. So first of all, I just want to show that heat pumps are already in your home. On the left, we've got some older, outdated technology, and on the right, we've got some more modern, newer technology. Many of these have heat pumps in them. An air conditioning unit is essentially a heat pump that's locked to only operate in one direction. A refrigerator, that's a heat pump. It's taking the heat that's inside the refrigerator and through the refrigeration cycle, moving it outside. And then a heat pump water, same thing. It's taking heat from the space around the tank itself and putting it into the water. Not to get too bogged down with complicated things, but I at least wanted to show you what is the refrigeration cycle. This is how a heat pump works. So it's comprised of a couple of technologies here: evaporator, compressor, condenser, and expansion valve. And well, how does it work? So it utilizes the changing phases of a refrigerant under pressure. Refrigerants are designed to become a gas at specific temperatures, so it's more efficient to unload heat into a specific source. So like I said, it's taking the heat from the outside of the tank in the room where it is, and it's through this refrigeration cycle moving that heat into the water. So why is it better to heat water with a heat pump compared to an electric resistance tank? First, let's look at the energy usage in a typical home. So everyone knows their HVAC system uses a lot of energy. That's the biggest source here. Typically it's about 46%. And it's pretty obvious when you have a really cold month because you see it in your bill, right? Your HVAC system, your heating system was working hard. So you see that. But the water heating is not quite as obvious. You know, it's spread more evenly throughout the year. Your heating costs are spread more evenly throughout the year for heating that water. So you might not be aware that it is such a big energy consumption device. It's typically the second biggest one in the house. That's why it's important. One of the measures that we use to measure the efficiency of the product of a heat pump water heater is called the COP, the coefficient of performance. This is a really simple metric. It's basically the energy output, which is the hot water, divided by the energy input. That's the electricity. Just for reference, a typical COP of an electric resistance hot water heater is about 1. So every 1 unit of energy that you put into the system, you get roughly 1 unit out. This is the same efficiency as your toaster oven. It's the same as your electric baseboard heaters. It's the same as your hair dryer. It's a very old and simple technology. And then how does that compare to a typical heat pump water heater? Well, like I said, with electric resistance, 1 unit of energy, that's on the left here, 1 unit of energy in equals 1 unit of energy out. But a heat pump water heater, much, much better. For every 1 unit of energy you put into the system, you typically get about 3.5 units of output. So the heat pump water heater COP is typically around 3 or 4, depending on the conditions. So you immediately can see a really big savings in your bill if you're switching from an electric resistance to a heat pump water heater. And you can see it right here on these stickers. So on the left, that's a typical electric resistance water heater. So it's over $500 of energy per year. And on the right, that's a heat pump water heater. So you see it's a fraction of it, just over $100 for a typical user. I don't want to go too much into other metrics, but just wanted to mention this so you're aware of it. The U.S. Department of Energy, their latest metric for communicating the energy efficiency of residential water heaters is called the UEF, Uniform Energy Factor, and that's been in place for a few years now. So that can give you a good kind of apples to apples comparison when comparing the efficiency of various water heaters. Now into some of the important things for homeowners to consider. Here's a list of simple installation considerations when determining if a heat pump water heater can be good for your specific case. I'll talk about installation location, space requirements, sound, managing the condensate that comes from the unit, and also any maintenance that is required. So first of all, where do you put the tank? It depends on your climate. So here's a picture of the Northwest states and also Wyoming. The more moderate climate zone of Western Washington and Oregon, it's climate zone 4C here on the chart. You have more flexibility where you can put the unit because it's warmer outside. But as you come into colder climates like Montana, you can see it's in climate zone 6. You have to be a little careful of where you put your unit. So if you're in Montana like I am, you can see in the matrix here, a basement, that's a good location for it, as is an interior room. But you probably wouldn't want to put it in a garage or an uninsulated room because it's too cold in those areas. And if you put a heat pump water heater in sufficiently cold temperatures, its efficiency starts to go down. And you can even have cases where the electric resistance backup kicks on, and then that defeats the purpose of having it. So you definitely want to make sure you put it in the right place and it's recommended in our climate zone here in Montana to place it in either a basement or within the conditioned shell of the house itself, somewhere in an interior room or utility closet. So sizing for these units. They typically come in 50, 65, and 80 gallon tanks. NIA we typically recommend to size up one tank size from what you had previously if you're coming from electric resistance. The reason for this is if you're able to rely on the heat pump itself rather than that electric resistance backup, it takes a little bit longer sometimes to charge or to heat the water. So giving yourself a little extra buffer is a good idea. And you can see the size of the families for each of these tank sizes here. In my own case, it's me and my wife. We've got 2 kids. And we also have an apartment, an ADU, with an adult living in it. So we've got 3 adults and 2 children in our household. We have an 80-gallon tank, and it serves us very well. Previously, when I lived in Seattle, it was just my wife and I. We had a 50-gallon heat pump water heater tank, and that was great for us there. So yeah, when you think about this, if you have sufficient space, we recommend sizing up just one size. The next consideration here is the space requirements. You've probably heard that heat pump water heaters put out some cooler air. So if you put this in a really small closet that's closed off, it can start to cool off that room too much so that you're going to be hurting the efficiency of the unit and starting to rely more on the electric resistance. So you'll find that most manufacturers recommend a certain minimum quantity or minimum cubic footage of space. Typically it's around 8 feet tall, 8 feet wide, and 8 feet long. Roughly 450 or 500 square feet from what NIA has seen in some of our testing. You're definitely going to affect the system performance if you go much smaller than that, although there are a number of interventions that you can take if you do have only a small room available. For example, in my house here, it's in a pretty small utility closet. So instead of installing a solid door, I've installed a louvered door, so it's able to pull air from outside of that closet. So now it's a sufficiently large space and doesn't overly cool the space around the water heater. So yes, the discharge air temperature is typically about 8 or 10 degrees colder than the air temperature around it, and it's also drier. So this is effectively a dehumidifier as well, which could be an additional benefit, maybe if you put it in your basement, for example. Okay, unit sounds. You might have also heard that heat pump water heaters create sound. Yes, that's true. It's typically in the range of 45 to 55 decibels. And you can kind of see where that fits in here on the right. It's louder than breathing, rustling leaves, whispering, and slightly louder than a refrigerator, but it's certainly quieter than all these other things above the line here. One consideration that people sometimes don't think about is, a refrigerator or a dishwasher. Those are around the same number of decibels as a heat pump water heater, but those are typically emitting the sounds lower and below or maybe behind cabinetry. The heat pump water heater is kind of at your ear level if you're standing, so it may seem louder than that if you walk right up to it, but it's not terribly loud. It's approximately the same as a refrigerator for reference. Let's see. Oops, I skipped a few slides here. Let's go. There we go. So condensate. Like I said, this is essentially a dehumidifier. It does create some condensate, so that is a consideration. You'll want to take note of any available drains, condensate pumps or lines that you have in your house. Hopefully you have one close by and easily accessible. You'll have to run a condensate line to active plumbing. In my case, it goes straight to drain in my house. Or you may need to utilize a pump if you're going uphill or even through the outside of the building. Water heaters can create about 2 gallons per day of condensate, although in our drier climate in Montana, I find it to be much, much less than that. In my case, I look at it each time I go by there. It's, I mean, typically not more than a dribble. But one other consideration in our cold climate, if you are pumping or moving the condensate through the wall to the outside, you need to consider if this is going to be a freezing issue. In Oregon, for example, they're starting to require some heat tape if you're going out in this same application. So yeah, please take note of that. Filters and maintenance, this is a really simple thing, but you need to be aware of it. Most heat pump water heaters have a filter that looks like the one here in the picture that needs to be cleaned on average every 1 to 3 months. But I mean, it literally takes 15 seconds to slide it out, wash it off, dry it off, put it right back in. And this is important because it protects some of the equipment inside the machine from getting dirty. And then you can also check that the condensate line is not clogged. Just visually inspect it. I've never had a problem with mine, not a single time. But the filter is the main thing that needs to be cleaned, and it's really simple. All right, lastly, I wanted to give you a couple of resources that we have available at Hot Water Solutions, which, like I said, it's one of NIA's programs. You can check out our website for Hot Water Solutions. It's hotwatersolutionsnw for northwest.org. You can find a bunch of videos, an overview of the technology, database of installers, technical articles if you want to read more about it. There's some good content there. And then we've also got a YouTube page at Hot Water Solutions where you can find some more videos on maintenance, installation, guidance, things like that if you intend to do your own installation. And with that, that's my final slide. So much appreciated for attending. Looking forward to hearing more of your questions shortly. Thank you.
Thank you so much, Blake. And we'll go ahead and pass it over to Devin from the city of Missoula.
Thanks, Blake. And as I'm pulling up these slides, just a reminder that if y'all have any questions, feel free to use that Q&A function. You can toss them in there, or if it's easier, the chat works as well. But my name is Devin Felicikia. I'm with the city of Missoula. I'll be talking a little bit about the costs of these appliances, how to potentially bring those costs down, and then I'll cover some of our local survey results from folks who have installed these. Thinking about usage cost, the thing I want to pull out here on this slide is that, as Blake mentioned, the heat pump water heaters are incredibly efficient. The energy factor under column 1, you can see heat pump water heater, the COP is around 3.5. So that's over 3 times more efficient than an electric resistance tank. So when you're thinking about the annual cost or the lifetime cost or the cost of usage, if you're switching from an electric resistance tank, you can expect to save a good bit of money. That said, if you're switching from a gas water heater, you may not experience much, if any, cost savings. Really depends, but just something to keep in mind. And also, I think it's important to note that this chart here was calculated using Northwestern Energy's gas and electric rates. So if you have a different utility, your calculation may look different and it may pencil out differently. So I'll send a follow-up resource at the end of this presentation if you want to play around with different electricity rates or propane rates or whatever you'd like. So next, I'm going to talk a little bit about the rebates and incentives that are available. There's quite a few because this is such an efficient appliance and folks want to incentivize it. So I'll talk about the local rebates that exist, utility rebates as well, tax credits, and then some financing mechanisms that can help support purchasing. So, thinking about local rebates, not every locale will have rebates or incentives, but I will say I think they're typically one of the more straightforward rebates available. So, the ones I'm familiar with in the state of Montana, the city of Bozeman offers a $500 rebate, and that's for anyone on Bozeman City Water to install a heat pump water heater. And then you can receive an additional $75 for participating in a satisfaction survey as a follow-up. And then both the city of Missoula and Missoula County, so anyone within county limits, are offering a $1,435 rebate for heat pump water heater projects. So those rebates are pretty straightforward. Like I said, we don't care what your old water heater was. We don't care if it's a new build or a retrofit. The main stipulation there is that it's a heat pump water heater and the location in which it's being installed. Thinking about utility rebates, they vary widely from utility to utility. So there's a lot of utilities in the state of Montana, so I didn't pull them all out, but I did pull out Northwestern's. Um, it's important to keep in mind that the reason why these utilities are incentivizing things like heat pump water heaters, typically it's to reduce their electrical load, so they don't have to buy or produce more electricity. So, because of this, it's important to consider or understand if they will supply a rebate for fuel switching. For example, if you're going from a gas water heater to an electric one. Some rebates don't. For example, Northwestern Energy offers a $3,000 rebate for heat pump water heaters, but that's only if you're going from an old electric water heater to a heat pump water heater. Thinking a little bit more about switching from gas to electric, I think it's important to keep in mind some additional considerations. You may need to wire a 240-volt outlet. You may need additional panel capacity, and you may need to think about capping the gas lines. So other things to keep in mind there. And yeah, as I mentioned, be sure to check kind of if you're fuel switching and if those rebates from the utility apply to you. Tax credits are another opportunity. They're currently available through the Inflation Reduction Act. Um, and personally, I think they're one of the more challenging credits to navigate. So just to note that I would consider discussing this with a tax professional if you're not very familiar with tax credits. But they're available through the Energy Efficient Home Improvement Tax Credit, also known as 25C. And this means that you can claim 30% of project costs up to $2,000 for heat pump water heaters, but you can also do it for other appliances as well. And then there's some financing mechanisms available also. The two I'm most familiar with are Montana Department of Environmental Quality's Alternative Energy Revolving Loan Program, and Clearwater Credit Union offers some energy efficient and solar loans. But I will note that like this is just what I'm familiar with locally, so be sure to check with your local financing provider to see if they offer any as well. Montana DEQ's program has a really low interest rate at 4% APR. I will mention though, it's pretty competitive and it fills up typically. Clearwater Credit Union has a couple of different loan programs to support things like heat pump water heaters, but their energy efficient loan comes in around 6.9 to 8.9% APR. And they also offer a solar loan where you can bundle solar with other upgrades like a new water heater at 6.9 to 7.25% APR. And one note about financing, I think these are great mechanisms, but typically I hear of them being used when folks are doing a little bit bigger of a project. So maybe you're replacing a few appliances or doing a retrofit on your home. It may not be the best option. I'm not sure about the eligibility if you're just financing a new water heater. Now I'm going to pivot a little bit and go into some of the satisfaction surveys that were received as part of Missoula's heat pump water heater rebate program. The numbers I'm going to share come from 29 of the recipients from the program, and these were just all of the folks who had responded at the point of time that I pulled this data from. In general, the average score across all of the quantitative questions was 4.62 out of 5, and 5 represents very satisfied. So most folks are satisfied with their new heat pump water heater. Most folks were satisfied with the installation process, and most folks were satisfied with the local rebate distribution process as well. So there's some short response questions as well. These in particular talk about the appliance. So the question that was asked was, what do you like about your heat pump water heater? I will mention that, so these were coded questions, and it was entirely up to folks what they put. So it wasn't like they're selecting these options. We just coded to categorize them. So just because only 4 people said the appliance was quiet doesn't mean that only 4 people thought the appliance was quiet. So keep that in mind with this data. But 16 folks mentioned that they like the energy efficiency and cost savings of the appliance. 8 folks mentioned that they like that it's all electric and doesn't use gas. 7 people said that just generally the appliance works well. 6 people like the adjustable settings and technology. Like I said, 4 people mentioned the appliance was quiet. 3 said it provided enough hot water. 2 liked the remote monitoring features. And 1 person liked that it acts as a dehumidifier. So we also asked folks what they don't like about their heat pump water heater. 5 people just mentioned the amount of hot water it provides, or something to that effect. 4 people mentioned the noise of the appliance. So kind of interesting. 4 people said they thought the appliance was quiet. 4 people also said that the appliance was noisy. So you can see there it really depends on the application, where it's at, things like that. 2 people mentioned that they had limited cost savings. 2 people mentioned an appliance malfunction. 1 person mentioned they didn't like the cool air discharge. 1 person had some challenges dealing with the condensate. Someone didn't like the app. And 1 person mentioned that the replacement cost would be higher. Now thinking about looking into the short responses related to the installation, when asked about the positives related to the install process, 17 folks had a great experience. So 17 out of the 19 here mentioned this. All went well, no issues, helpful installer as well. Some of the negatives when asked about the install process, 6 folks mentioned that the technician didn't seem knowledgeable about heat pump water heaters. 2 people had to move their water heater locations. 2 people mentioned managing the condensate discharge. 2 folks mentioned just coordinating with contractors in general was a challenge. 1 person mentioned that they had to interact with multiple contractors, so an electrician and a plumber. The permitting process, long install time, and product delays were other things folks mentioned. So I think the takeaways here are that in general, folks were very excited about their new heat pump water heater. There were some aspects that posed challenges, but I think the coded responses help us better understand what those were, at least in these few examples. It's kind of interesting, and I think I like to see this, that most of the things that people didn't like related to the appliance could be addressed with additional considerations prior to the install. So the main complaint we saw was folks not having enough hot water. And like Blake mentioned, this can easily be addressed through either a better understanding of the appliance modes or sizing up your water heater. And then the biggest challenge related to the installation process was that the installer didn't seem to be very knowledgeable about heat pump water heaters. So when it's time to install, be sure to do your research and feel free to reach out to us. I'll share these slides afterwards, so you don't have to write down our contact info now. But Ali and Bozeman, myself and Missoula are always glad to chat about this a little bit further. But thinking about knowledgeable contractors, I can pass it over to Devin with Garden City Plumbing and Heating. And Devin, if you want to just share a little bit about your experience with these heat pump water heaters and kind of what your perception is as an installer.
So yeah, what I was sharing is that I'm a big proponent of heat pump water heaters. I have one in my own home, and we also have one here in our office building. And so in the right application, I think they can be a perfect technology. But I do want to acknowledge they're not for everyone, and they aren't a fit in every situation. When it comes to heating and air conditioning solutions, as well as hot water solutions, there's no silver bullet. But this does fit a tremendous number of applications. So when we look at it, things that I do love about heat pump water heaters is that they're actually, from an installation standpoint, not dramatically different from a traditional electric tank. So the uptake of information for a contractor to be able to install a new system is pretty quick. It's a fast learning curve, and even though some have said, hey, my plumber isn't particularly familiar with this, when it comes to these technologies, a well-experienced quality contractor can really get up to speed fast. So if they aren't experienced with it, some pretty quick, simple training can get them to a point where they're knowledgeable enough to be helpful to most people. Things that I do watch out for when I'm looking at a home, and one of the primary things that I'm going to call you Other Devin addressed, is the space requirements, and one of the big complaints being that they had to move the heat pump water heater. That is something that in some applications, certain appliances have configurations where the duct ports or the exhaust might come off the back or in different locations. And so we have had applications with specific appliances where we've had to move the water heater a few feet to allow for appropriate clearances for the appliance, but also for serviceability. We want somebody not just to be able to put that in once, but we want to be able to work on that in the future. So you need to allow space for that. Other considerations that we might have for moving a water heater might be if you have a long delay in hot water arriving at the faucets or fixtures. So I have had some homes where we've looked and found creative ways to get the appliance closer to those so that you have a quicker delivery rate. You're not delaying the time from the appliance to the fixture. And so when we're looking at heat pump water heaters, one thing I did find interesting, the picture that I believe was in Blake's slides showed a heat pump water heater with a recirculating pump. But that is something that when you're considering an application, you may not want to install a recirculating pump on a heat pump water heater because that heat pump water heater has a slow recovery rate. You could, by using a recirculating pump, actually lose as much energy as you're saving with that circulating through. Essentially, that recirculating line becomes much like a radiant heat loop. So if you're having problems with heat pump or with hot water arriving at your faucets with a heat pump water heater, we might want to think through some more creative solutions for how to do that. But other great things with heat pump water heaters, that if the space is a little too small, the ability to duct them to different areas also makes them very flexible. That's what I did in my own home. And that can allow you to pull air from a different space. So if you're concerned about it cooling a specific area that it's in, you can draw air from a different room and use wasted heat from a space that might be a little bit too warm and actually provide productive use of that heat. I think outside of that, other things I hope for in the future are to see greater cold climate heat pump functionality like we do have on traditional air source heat pumps, where you can draw air from outside at sub-zero temperatures and still provide usable heat. I'm optimistic that we'll see more options like that come in the future. But even as they stand now, if most heat pump water heaters are rated to around 37 degrees. So if you end up pulling outside air much of our winter, you'd be engaging your electric strip heat or the backup heaters in the unit. However, if you look over the course of the entire year for that, if you were to draw outside air compared to an electric tank, I believe you'll find that you're still saving a considerable amount of money, even if you have times that are pulling in air that are below that point. So again, really flexible applications for these, and a lot of homes that they work very well for.